Hi there, and welcome to my channel. In this question, we are given three sequences, and we are being asked which ones of them converge. And so let's look at the first sequence, and let's even look at if it converges, what will be the limit of this sequence. So let's look at the limit as n goes to infinity of an, which is equal to limit as n goes to infinity of 5n divided by 2n minus 1. Let's divide both numerator and denominator by n. We get limit as n goes to infinity of 5 divided by 2 minus 1 over n. And 1 over n, limit of 1 over n is 0, so the limit here is 5 over 2. So we not only show that it converges, but we even found which number it converges to. So the first series converges. Let's also look at the third series. And so similarly, the limit as n goes to infinity of an for the third series is equal to limit as n goes to infinity of e to the power n divided by 1 plus e to the power n. Again, dividing by e to the power n, both numerator and denominator gives us limit as n goes to infinity of 1 over e to the negative power n plus 1. And again, similarly here, the limit of e to the negative n is equal to 0. So this is equal to 1 over 0 plus 1 or equal to 1. So again, series number 3 converges, and we even found this limit. For series number 2, let's do it a little differently. So let's look at the limit of the following term, an plus 1, to the ratio of an as n goes to infinity. And so, depending on what this limit will be, we will be able to say whether the series converges or diverges. And it will converge if this ratio is less than or equal to 1, then it converges. And if it's greater than 1, then it diverges. And it's intuitive because when the ratio is equal to 1, that's actually at some point gives us the limit of that sequence. If it's less than 1, then this sequence decreases as n increases, and actually the limit will be equal to 0. And if the ratio is greater than 1, at infinity, each following term is just that number greater than the previous term, so it diverges. So let's take a look here. This is limit as n goes to infinity, an plus 1 over an for series number 2. This is equal to limit as n goes to infinity of the ratio e to the power n plus 1 over n plus 1 over e to the power n over n. And so this is equal to limit as n goes to infinity of e to the power n plus 1 over n plus 1 times, and dividing by a fraction is the same as multiplying by its reciprocal. So this is times n over e to the power n. And this is equal to, let's go further here, this is equal to the limit as n goes to infinity, and let's combine the like terms here, e to the power n plus 1 over e to the power n times the limit as n goes to infinity, n over n plus 1. And we can see here that in the first ratio, we get limit as n goes to infinity of just e times the limit as n goes to infinity, and here we divide both numerator and denominator by n, we get 1 over 1 plus 1 over n. And so this is equal to the limit of e as n goes to infinity, it's just e, and the limit of the ratio 1 over 1 plus 1 over n is 1 over 1 plus 0. So this is equal to e. And e is greater than 1, so this series diverges. So we see that getting back here, that this series actually diverges. So the answer is D, only 1 and 3, first and third series converge. Thank you, and for watching. If you like this video, please don't forget to click the like button, write me your comment below, and subscribe to my channel, where you can find more solutions to various AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.